Number one. Why did you do that?
See, that doesn't bug me up. I wrote down the answer and stick it with it.
And so yesterday we looked at an equation, and the equation for percent remaining demonstrates the relationship that you saw on the same graph. Y equals 1 over 2 to the x. Not y equals 1/2 x, but 1 over 2 to the x, where y represents the percent remaining, and x represents the number of half-lives that have passed. Question number 2. Fill out this graph with the appropriate corresponding curve. The graph that would go with that then, on the y-axis, would be percent remaining of the radioactive material. And the x-axis would be number of half-lives. Why don't biologists go past 5 on the number of half-lives?
Because it goes below 1 and you can't have
Yeah, like it's going to be infinite, right? We're just going to keep on dividing things in half and dividing things in half and dividing things in half. And for us as biologists, while we recognize that mathematically that is possible, we recognize that in the physical world it can't exist. So we stop at about 5. If the equation is, as it is, y equals 1/2 with an x up there, substitute 1 in for the x. Solve for y. Does it? We all agree?
Yeah.
Some of you are like, I'm just sitting here. Substitute 2 in. All agree? And 3? And 4? And 5? You're like, 2 times 2 times... What's 16 doubled? 1/32. And of course 0. And we'll stop there. Either way you approach these problems, you can use the graph or you can use the equation. Some of you are more comfortable with the equation, and that's fine. And some of you are going to be more comfortable with the graph, and that's okay too. But what I need to make sure you know to show your work. Because on your test, it's going to say show your work. And you won't get credit for it if you don't. Now, if you used the graph to do your work, just draw the graph. Remembering all graphs have labels on both axes. So those axes must be labeled. Sample problem. Let's see here. has 150 grams of carbon-14. This is 25% of the original sample. How many half-lives have passed? 2. You guys agree that if we said y equals 1, and we said, well, 25% is the same as a quarter, right? So how do we make sure that we solve like 2 to the x equals 4? You know that it's 2 squared, right? Turns out I appreciate that some of you are not familiar with the logarithm that would be required to solve any of these problems if they are not even numbers. But are you comfortable solving if they are even squares, like if they're perfect squares? Okay. If I just said logarithm and you were like, what? Don't panic. I edited out those questions. If you got it, in which case I have like the super extra bonus round questions for you. Bonus round questions? It's good. It's good. What was the original sample size?
grams.
600 grams? How'd you get there?
Because 25% times 2 is 50, that's 300. So that gets you,
Okay. If the half-life of carbon-14, well, it's not if, the half-life of carbon-14 is 5,730. How many years have passed since this sample was originally created? If 5,730 years is the half-life of carbon-14. 11,460, right? 2 half-lives. Can I speed up the half-life of carbon-14? Can I slow it down? What if I heat it? What if I cool it off? What if I add more carbon-14? Never going to change, is it? Excellent. So